In this video, we're going to be talking about implicit differentiation. And first things first, I'm gonna tell you the difference. So I'm gonna differentiate, or tell you the difference, not the derivative differentiate. But I'm gonna tell you the difference between an implicitly defined function and an explicitly defined function. Explicitly defined. So the reason why I'm telling you this is because, well, you're gonna know where the name implicit comes from. So explicit functions, the functions that are very useful. Y is equal to some function of x. A nice example of this would be y is equal to 3x squared plus 2x minus 1. Right? This is an explicitly defined function since x is equal to some function of x. Y is equal to some function of x. But implicitly defined function is where a constant is equal to some function of x and y. Now, x and y are still tied together. X is still the independent variable in this case, and y is still the dependent variable. So if you put x and y in a graph, x would be on the horizontal axis and y would still be on the vertical axis. But the way you set up this equation is differently. An example of this would be 3 is equal to 2x plus 3y. Another example of this would be 4 is equal to xy plus 3y squared. Right? But with implicit differentiation, you have to use chain rule in ways that aren't as obvious as a seam. Now, for implicit derivatives, you take the derivative of an implicitly defined function. So the functions you've been using are all explicit, but now they are implicit. So what's the name of the derivative for an implicit function? An implicit derivative. So we can do some problems right now, and I'll show you where and why chain rule comes into this mumbo gobbledygook. For this problem, you have a very canonical formula or function of a circle, a radius 5. So let's take the derivative of this using implicit differentiation, since this is an implicitly defined function. 2x plus 2y. That makes sense, right? Use power rule on these two terms, and you get 2x plus 2y. Now, for the 2y, you have to multiply it by dy over dx. Why? Well, take the derivative of 25, it's 0. Well, why do you have to, no pun intended, why do you have to multiply 2y by dy over dx? Well, dy over dx represents the derivative of a function of x, right? Well, since y is still a function of x, in this case, although is an implicitly defined function, y is still a function of x. Y is still a dependent variable to x in this case. So, in cases like this, where you have an implicitly defined function and y is still a dependent variable to x, you must use chain rule. Now, chain rule isn't as obvious here. Where does chain rule come in, right? You're probably scratching your head. You're wondering, where the hell does chain rule come in? Well, let's look at chain rule. Well, chain rule states that if you have an inner function, you have to multiply the inner function. You have to multiply the derivative of the outer function by the derivative of the inner function, g. Well, since y is a function of x, technically, y squared here is the outer function, and a function of y is the inner function. So technically, this is f of, okay, you know what? Let's write this. Y squared, let's bring it down. Technically, y squared is a function of x squared. Well, there's something squared. So something squared is the outer function in this case, f. And the inner function is the function of x. So if you want to take the derivative of this, you bring down the 2 using power rule to get 2f of x, and you must multiply this outer function, f prime, by the derivative of the inner function. And the inner function in this case was our function of x. So the derivative of our function of x is f prime of x. And f prime of x is also dy over dx, right? And 2f of x is also 2y. So 2y dy over dx makes sense in this case. Now, if you want to take the lazy route and not care about where you use chain rule, then just memorize this interesting fact. not interesting. Guess math can be interesting for some people. Okay, but just memorize this fact. If you're taking the derivative of anything with the variable y in it, just multiply by dy dx. Just multiply by it. So if you have like 3y squared like plus x, you want to take the derivative of this using implicit differentiation. Just 3y over x. Oh, there's a y here. Okay. Take the derivative of this, power rule, 6y, right? Bring down the 2, subtract the exponent by 1, and then multiply by dy over dx. Derivative of x is just 1, derivative of 1 is just 0. Right? This is just another example problem. It has nothing to do with the previous problem. But I'm just showing you. You see y there, just multiply by dy over dx. That's how I passed Calculus 1 with this. Well, I just recently learned the reason why for the chain rule, but let's just go back to the problem. So, how do you take the derivative of this? How do you find the derivative of your implicitly defined function? Well, simply isolate dy over dx. You want dy over dx on one side of the equation. So, how do we do that? Well, let's move all the dy over dx terms onto one side. So dy over dx here, right? And then we can cancel out the 2's. And then we can divide. Let's see. Let's not divide yet. And we get a function that looks like this. Well, we can divide by negative y on both sides. Correct? If we divide by negative y on both sides, we get x over negative y is equal to dy over dx. And then this right here is your derivative. There you go. Just do a little bit of algebra once you take the implicit derivative. And then you can get your isolated function for your implicit derivative. All right, let's take the derivative of xy is equal to 1. So we have to use product rule. So what's product rule? Let's rewrite that. F times g is equal to f prime g times g plus f g prime. So in this case, there's two functions, x and y. And in this case, there's two functions with product rule, f and g. So x in this case is analogous to f, and y is analogous to g. So we need to take a derivative of f. The derivative of x is just 1. Okay. The derivative, nope, no more derivative. And then g is just y. We multiply this by y. And you put a plus, not equals, oops, plus in between. F is x, correct? And g prime is the derivative of y. Well, the derivative of y is 1, simply. But when you take the derivative of something with the y value in it, you have to use dy over dx. So this is what we end up with, right? And the derivative of 1 is just 0, so we put 0 on the side. If we simplify this, get rid of all the 1's, we get y plus x times dy over dx is equal to 0. We must move all the dy over dx terms on one side of an equation. We get negative x dy over dx. And then if we go up here for more space, divide by x on negative x on both sides, you get y over negative x is equal to dy over dx. Since these cancel out. So, why did I just circle the dy over dx? So this is the derivative of xy is equal to 1 using product rule. Now, keep in mind, when you're using product rule or quotient rule or anything like that, and you see the format of f prime g, g in this case was analogous to y, make sure you don't put dy over dx next to this, since you didn't take the derivative of anything related to y. For this problem, we have another implicitly defined function. It's not equal to a constant this time, but it's still implicit. So let's take the derivative of this. Well, we have to use chain rule and product rule together here. So sine's derivative is cosine of xy, right? And then we have to use chain rule, since there's an inner function and an outer function. The outer function in this case is sine. The inner function in this case, okay, I should have just not moved it 3 times there. But the outer function in this case is sine, and the inner function is xy. So we need to take the derivative of xy. Well, again, we use product rule. So what's product rule? Fg is equal to f prime g plus fg prime. Right? So f in this case is x, g in this case is y. Let's do this quickly. F prime is 1, since f is x, y is g. G is y plus f, which is x, times g prime, which is y. But the derivative of y is just 1. But when we derive y, we must multiply it by dy over dx. Okay, how about this? The other side of the equation. Well, the derivative of x is just 1. And the derivative of y is just 1 times dy over dx. So we can omit the 1. Now, look what we have. We can simplify this. We get y plus x dy over dx times the cosine of x y plus 1 plus dy over dx. Now, what can we do? Well, we must distribute this cosine value. We have y cosine of xy plus x cosine of xy times dy over dx is equal to 1 plus dy over dx. Now, most of the time on tests, your implicit derivatives will look like this. Trust me, taking the double implicit derivative is even more annoying. Oh my god, that it has so many room for algebra mistakes. But just I'm gonna worry about single derivatives for now in this video. Yes, there's double implicit derivatives. Oh, boo-hoo. Okay. We need to move all the dy over dx terms on one side, so we get cosine of xy minus 1. I move the 1 over, is equal to negative x cosine of xy. I move the cosine value over on the right side of the equation, times dy over dx plus dy over dx. Well, right here, we can factor out dy over dx, so we get y cosine of xy minus 1 is equal to dy over dx, x cosine xy plus 1, right? Factor out dy over dx from this term, and I factor out dy over dx from this term, and then I ended up with 1, right? So, once you have this, you can just divide this on both sides, this term on both sides, to get y cosine of xy minus 1 over negative x cosine xy plus 1 is equal to dy over dx. So just a little bit of algebra there, and keeping track of everything using chain rule to get the thing out here, and product rule to get the derivative of xy. For this problem, we have another product rule, chain rule, blah, 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 blah. So, this is going to be a long one, but we have to use product rule again. Let's write down product rule to help you guys visualize. So f times g is equal to f prime g plus f g prime, right? So we need to do product rule twice, since there's two times you have a function times a function. X cubed is f in this case for the first derivative we're going to do, and ln of y is g in the case. So the derivative of a function times a function is f prime. F prime is 3x squared times g, which is just ln of y, plus f x cubed, which is x cubed, times the derivative of g prime. Not derivative, times g prime. So ln of y is the outer function in this case. So we have to use chain rule here. So ln of y is the outer function. The derivative of ln of anything is just 1 over what's inside the parenthesis. And then the derivative of the inner function, which is y, times the outer function. The derivative of the outer function, which is 1 over y, is dy over dx. So remember chain rule, the derivative of the inner function multiplied by the derivative of the outer function. So the outer function is ln, 1 over y, times the derivative of the inner function, which is just y. And the derivative of y is 1 times dy over dx. We put a plus here, since that's the term, that's the operation in between, and then we get to use product rule again. So this is f, and then this is g in this case. So f prime is 3y squared dy over dx. Anything with a derivative of y has to be multiplied by dy over dx. times g, which is just ln of x, plus f, which is just y cubed, times g prime, which is just 1 over x. Now, all we have to do is simplify this a little bit. So we get 3x squared ln of y plus x cubed over y, x cubed over y dy over dx, plus 3y squared dy over dx, ln of x, plus y cubed over x is equal to 0. Right? Derivative of 1 is just 0. So, let's move all the terms onto one side of this hefty equation. So we have 3x squared ln of y plus y cubed over x is equal to negative x cubed over y dy over dx plus 3y squared ln of x dy over dx. We can factor out dy over dx, and if we do that, I'm just going to erase this so I can, you guys already know what I did here, so I'm just going to erase this and then factor out dy over dx. So factor out dy over dx, you get you get negative x cubed over y minus 3y squared times ln of x. Well, we could just divide this term onto the other side to get 3x squared ln of y plus y cubed over x over negative x cubed over y minus 3y squared ln of x. It's equal to dy over dx. So implicit differentiation. Booyah. And most of your problems are going to be this annoying. Tough, right? I took calculus 1 as well. But yeah, most of your problems are going to be this annoying, especially for double implicit differentiation. Oh, I have to make a video on that one. Oh, Jesus Christ. Yeah, that's enough problems for today. I'm gonna chill for now. So, if you have any questions, put it down in the comment section. And if you found this video helpful, consider subscribing and liking the video. Thank you for watching.